Today we discuss about the law, that is Stokes Law. Firstly, the scientist Stokes define or state the law in case of any spherical body, and this body is falling into fluid or into liquid, then the viscous force from that liquid, and that viscous force depends upon the three different parts, that is, first is radius of spherical body, second is velocity of that spherical body, and coefficient of viscosity of fluid. There is a relation between the viscous force and coefficient of viscosity, velocity of the given body, and radius of that spherical body, and this relation gives this scientist Stokes, hence that law is called Stokes Law. The statement, the viscous force, we say F the viscous force acting on spherical body or sphere falling, that spherical body or sphere falling through a viscous medium is directly proportional to, number 8, the radius of sphere, say small r. Secondly, this viscous force is directly proportional to velocity of the sphere in viscous medium, and number 3, coefficient of viscosity of the fluid. Velocity of, suppose this velocity is v and coefficient of viscosity is eta. The statement of Stokes law, the viscous force F acting on spherical body or sphere in the falling through viscous medium is directly proportional to, number 1, the radius of spherical ball or spherical body or sphere, number 2, its velocity of ball in this given medium, and number 3, the coefficient of viscosity. Therefore this F is directly proportional to R radius, phi velocity, and eta coefficient of viscosity. Therefore, Fv is equal to some constant K R phi eta, where this constant K is called proportionality constant and its value is obtained 6 pi. Therefore, the viscous force Fv is equal to 6 pi R phi eta. This equation is called Stokes Law, or equation of Stokes Law. Fv is equal to 6 pi R phi into eta, where Fv is viscous force, 6 pi is constant quantity, R radius of spherical body or ball, phi velocity of that ball in viscous medium, and eta is the coefficient of viscosity. This is the Stokes law. Then another we obtain the equation of terminal velocity. Equation of terminal velocity. Now we consider a glass tube. This glass tube open at upper end and closed at bottom end, and this glass tube filled with the viscous fluid or viscous liquid, and a spherical body is dropped or falling into this, and suppose this is the ball, spherical ball, and this spherical ball drop or falling in this viscous fluid, then the ball is slowly moves top to bottom and attempts some time to reach the bottom end. In this case, now the equilibrium condition of that ball, or we assume that the ball or spherical body at that position, the two forces acting on that sphere or rigid ball is first its weight, total weight acting vertical downward. The first force is weight of ball acting vertical downward, that is W is equal to mg. This is nothing but the downward force or force due to gravity. Say Fg is the force due to gravity acting vertical downward, and another force, second, the upthrust and viscous force, upthrust of this ball and viscous force from this viscous medium or viscous fluid acting, both are acting vertical upward. Hence, the total upward force, say F, is equal to F U is upthrust force and plus F V is the viscous force. These two forces acting vertical upward, F U and F V. These two forces acting vertical upward and its weight acting vertical downward. When this ball at in equilibrium position, when the total upward force, the total upward force is equal to total downward force. Therefore, the total upward force is the addition of these two forces, and total downward force is the force due to gravity, that is M into G. Therefore, we obtain the relation of terminal velocity. The total upward force is nothing but Fu plus Fv is equal to W or M into G. Now let the rho is the density of this viscous fluid and sigma is the density of that spherical ball. Now the Fu means the upthrust due to this ball is shape of that is spherical. Now the volume of sphere, you know the volume of sphere is 4 by 3 pi r cube sigma into G. 4 by 3 is volume and this is the density. This is the total weight of that upthrust plus Fv means viscous force, and that viscous force is 6 pi r3 into eta, which is equal to M into G, where mass is nothing but volume into density into acceleration due to gravity, or 4 by 3 pi r cube sigma G plus 6 pi r p eta is equal to volume of sphere is 4 by 3 pi r cube rho into G. This is the total upward force and this is total downward force. Therefore, after simplifying 6 pi r p eta is equal to 4 by 3 pi r cube rho C minus 4 by 3 pi r cube sigma into G. Therefore, 6 pi r p eta is equal to 4 by 3 pi r cube rho, r cube into G is common into bracket rho minus sigma. Now you find out value of this V, and that V is called terminal velocity. Therefore V is equal to 4 by 3 pi r cube G into bracket rho minus sigma into 1 upon 6 pi r theta. Therefore, phi is equal to, P means, which is phi is terminal velocity, phi is equal to pi, pi cancel, r, 1r cancel, 2, 3, in 3, no, hence 2 by 9. 2/9. R square rho minus sigma into G divided by theta. Phi is equal to 2/9 into R square rho minus sigma into G divided by eta. This equation is called equation of terminal velocity. Also we determine the value of coefficient of viscosity. Eta is equal to 2/9 into R square rho minus sigma into G divided by P. Using this formula, we can calculate the coefficient of viscosity, where 2/9 is constant, R is radius of spherical body, rho means density of viscous fluid, sigma is density of that ball, G is acceleration due to gravity, and V is called the terminal velocity. This equation gives the equation of terminal velocity, and this equation gives the viscosity or coefficient of viscosity.